For the navigation, at least two stations are required for coverage. Okay. So the area of coverage, it depends on two parameters. First one is the maximum range of the station and the distance between the station. Okay, distance between the station. So this service area depends on latitude of the region, season of the year, and the time of the day. Okay. For the ground wave, the average range over the sea in latitude is around 600 kilometers, and in the equatorial region about 500 kilometers. Okay. So the range over a land is less, about half or third compared to sea. Okay. So the sky wave range, which are the same over land and sea. Okay. It is higher, appreciably higher. So the accuracy of LORAN system is dependent on which time interval measurement can be made. It is also dependent on the signal strength. The other factor which is dependent on the accuracy is in which the ground stations are going to be synchronized. Okay. After achieving these two factors, the probability of error is around 1.5 to 2 microsecond in the measurement of time interval. Okay, it can be have this delay of this 2 microsecond for the arrival of signal. Okay, because the error may be introduced because of the skywave propagation, as the path taken by the skywave is longer one via the ionosphere, as the ionosphere is made up of full of ions which are randomly located in the ionosphere, okay, which also affects my propagation of the signal. Okay. Second is LORAN-C. So LORAN-A and LORAN-C, what is the difference? The difference is in the operating frequency. LORAN-A was the first developed. After that, LORAN-C was developed, which operates in the band of 90 to 110 kHz. It is developed after the World War II. As a disadvantage of the previous, LORAN was removed, that is the lower coverage area. Okay, lower coverage area was there in the LORAN-A, so it is going to be reduced. That error is going to be reduced with the help of LORAN-C, right? So with the help of low frequency, the ground wave transmission is very much larger. Okay, and attenuation is nearly same, whether over it is land or over the sea. Alright. So as the larger ground wave range permits the greater separation between the master and the slave, right? The range of LORAN-C is several hundred of kilometers. So with the help of limited bandwidth which is available for LORAN-C, the pulse width has to be very long, and this reduces the accuracy, but it is still higher than the LORAN-A. So advantage of using LORAN-C is its operating frequency, larger coverage area, and the accuracy, which is comparably higher than LORAN-A. Okay. So the accuracy is going to be achieved using the Keisham atomic clock for generation of carrier signal of the transmitter, and the synchronization of the transmitter is proper, then pulse matching is going to be easy and less error is going to be occur in the transmission side. Okay. So compared to LORAN-A, the LORAN-C has the probability of error, arrival of signal from the transmitter is having a delay of 0.1 microsecond. Earlier for LORAN-A it was around 1.5 to 2 microsecond, right? Peak power is 1 megawatt, and in the LORAN-C transmission envelope is used. Alright. So in LORAN we have studied LORAN-A and LORAN-C. Based on that, we have compared according to the frequency, its range and its accuracy, right? So the second hyperbolic navigation system is the DECCA navigation. So what is the operating frequency band? Operating frequency band is LF. Okay, that is between 70 to 120 kilohertz, which uses the unmodulated continuous wave. Earlier in LORAN system, it uses only a pulse radar, or we are going to transmit it in the form of pulse, right? But in the DECCA navigation, we are going to use only a continuous wave. So in DECCA navigation system, the fix is going to be obtained by measuring the phase difference between the signals of two stations, which is going to be phase from. Okay, because the synchronization is worst. So in the DECCA chain, which consists of 4 stations, 1 is master, 3 slave. In LORAN, the chain consists of 3 stations, 1 master, 2 slave, and here we have 1 master, 3 slaves. Okay. So the master station is at the center and the 3 slaves at the corner of the triangle. Okay. So this arrangement gives the 3 set of hyperbolic position line, 1 set corresponding to master and each to the slave. Alright. So this fix is going to be obtained over considerably area by the intersection of 2 hyperbolic lines. Right. A DECCA navigation system in which each transmitter has different frequency, so the radiation from the each station will differentiate by the receiver, right? Generally, harmonically related frequencies related by each transmitter and the phase measurement done at the common harmonic frequency, which is obtained at receiver by using a multiplying circuits. Now we are going to focus how this is going to be done. So over here, block diagram of DECCA receiver. It is a DECCA navigation system in which you are going to identify there is a RF amplifier, oscillator, divider, phase comparator, mixture, and another RF amplifier. Right? So antenna is there to receive the signal. Okay, as there are 2 RF amplifiers which is having a frequency having F1 and F2, right? That frequency F1 is going to be applied to the oscillator, as well as after the oscillation it is going to be applied to the mixture. Why? Because it will generate the difference of these 2 frequency F1 and the F2 to generate the IF, intermediate frequency. Alright, and after generation of IF, that means a down conversion, subtraction of these 2 frequency, the IF is going to be applied to the phase comparator, right? And after the phase comparison, it is going to be, we can say, the phase comparison, that frequency is going to be applied as IF frequency, and that phase is going to be compared with the frequency which is going to be applied from the RF amplifier, that is F1, is going to be divided with the help of divider, and that frequency is going to be applied for the phase comparison. Alright, so this is the DECCA receiver. So the DECCA navigation is the low frequency hyperbolic navigation system. What it compares? It compares the phase difference of radio signals, which is emitted by the several radio stations. Right? So this method of navigation was used in aeromagnetic surveying before the advantage of the global positioning system over water and the ice, where the visual flights path recovery methods were not reliable. Alright? So over here we have studied in chapter number 10, that is a hyperbolic navigation system. We have studied what does it mean, what are different types of hyperbolic navigation system like LORAN, DECCA, Omega, right? And in the LORAN we have studied LORAN-A, LORAN-C, that are going to be identified or differentiated with the help of operating frequency, its accuracy and its range. We have studied the DECCA receiver. Okay, what is its operating frequency, its range as well, right? So over here chapter number 10, that is the hyperbolic navigation system, is finished. Alright, but still if you have any doubt, you can ask me anytime on my video email ID. We are going to start chapter number 11 in the next session. Till then, thank you for your attention.